So now looking at inverse functions, we have our function machine once again. So our function machine f of x takes input values, our x values that go into the function, and out come our y values, or output. But what if we knew what our output values were, and we wanted to put it into a machine to tell us what x started as? Using an inverse function, we can use the output, put it into our inverse function to determine what x would have started off as. So for example, if we have the function f of x is equal to x squared, we can use an input value of x is equal to 2, input it into our function, and we get an output of y is equal to 4. And suppose there was some inverse function that could take our y value of 4. We're looking for some inverse that will determine what x started off as, so that could determine that x was in fact equal to 2. And we're going to look at finding this inverse of the function. So for a function f of x, the inverse function is written as f inverse of x, or inverse of f of x, and this is denoted as f to the power of -1. It's not actually an exponent of -1, this is just notation to show that it is the inverse of f. In Math 145, we used inverse functions without necessarily calling them inverse functions in order to solve the following equations. So for example, if we know that sine of x is equal to 0.5, we can solve for x by using the inverse sine function. So x is equal to sine inverse of 0.5. We can solve for x if x squared is equal to 25 by taking the square root of both sides of the equation, and we find that x is equal to the square root of 25, and x is equal to 5, and that's only assuming that x is greater than 0. We need to put a restriction on x here, otherwise it would not be described as a function, because there are two values of x such that x squared equals 25, both positive and -5. By putting this restriction, it allows us to restrict the domain to just be dealing with a function. And the last equation we can solve is that 3 to the power of x is equal to 81, and we solve this using logarithmic equation. So x is equal to log base 3 of 81. So if f of x is equal to sine x, the inverse is f inverse of x is equal to sine inverse of x. If f of x is equal to x squared, then the inverse, f inverse of x, is equal to x to the power of 1/2, or the square root of x. And lastly, if f of x is equal to 3 to the power of x, then its inverse can be written as log of base 3 of the exponent, which in this case is x. So the process to find the inverse formula is to solve the equation y equals f of x for variable x, and then we exchange the x and y. We'll do so in the following example. For f of x is equal to 2 divided by x minus 3, we want to find the inverse function. Okay, so the first thing we do, let's write this as y is equal to 2 minus x minus 3. So all we've done is taken our equation for f of x and replaced f of x with y. Now we solve for x. Remember to keep this entire denominator together, but we can exchange along the diagonal, so we're essentially cross-multiplying. And we end up getting that x minus 3 is equal to 2 divided by y. And now to solve for x, we bring 3 to the other side of the equation, the negative 3, and it becomes positive. We get 2 divided by y plus 3. Now the final step to express our inverse function, so we write it that the inverse of f of x is equal to, so you take what we solve for in terms of x and we are going to exchange the x and the y. Okay, so we get 2 divided by x plus 3. Like so many things in mathematics, we're able to verify whether or not two functions are in fact inverses of each other. So in order to verify that, we want to calculate f of g of x, and if they have inverse relationships, then it will evaluate to x. So let's try this with the previous example. So recall we have f of x is equal to 2 divided by x minus 3, and our inverse function, which we're going to call g of x, is equal to 2 divided by x plus 3. Now to check if we have an inverse relationship, we want to calculate the composite function, so f of g of x, and that is f of 2 over x plus 3. To calculate this, we take 2 over x plus 3 and put it into f of x everywhere where there's an x. So this becomes 2 over x plus 3 minus 3. And I'm going to show where my substitution was. So I've taken the 2 over x plus 3 and subbed it into f of x. Now if we simplify this, we end up getting 2 divided by 2 over x plus 3 minus 3, which cancels out to be 0, and we can rewrite this as 2 divided by 2 over x, and we're going to invert and multiply, and you'll see that the last step of simplification is that our 2's cancel out, and we are left with it being equal to x. Therefore, we can say that f of x and g of x are inverses of one another because when we calculated the composite function, f of g of x, it was equal to x as required. A practical way to think about functions and their inverses would be to think about encryption. So if you write an encrypted message, you typically expect that someone else will have to decrypt it later. So encryption is a way of thinking of a function. If you receive an encrypted message, the inverse would be considered the decryption of the original message. And throughout this course, we're going to continue to use function notation as well as the inverse of a function as we look at various types of functions in Unit 2.